There's two ways to classify triangles, and the first way is by their angles. What kind of angles do we have? What kind of angles are there? Acute, acute, obtuse, right, and straight. Okay, we don't have any straight angles in triangles, right? Because you couldn't make a triangle with a straight angle. It just keeps going. There's no triangle there. So, if all three angles are acute, what does acute mean? Less than 90. If all three angles are acute, then it is an acute triangle. How about this? What kind of triangle is this? Right triangle, because it has a right angle. What are the two non-right angles? What kind of angles are those? These are acute. So it's got one right angle. Is it possible to have a triangle with two right angles? You guys know why not? Okay, because lines that are perpendicular to the same line are parallel, so they'll never touch. It's like the two walls going straight up. They'll never touch each other. Can't make a triangle with that. Okay, so what am I missing here? What kind of triangle is that? What kind of angle is that right there? Obtuse. And what are the two non-obtuse angles? Acute. So it's got one obtuse, two acute. Is it possible to do two obtuse angles in a triangle? No. It's not going to come together. So, yeah. Based on the angles, if it's acute, it's got to be all three acute. If it's right, you're going to have one right angle. It's obtuse. So a right triangle, I should warn you, it might look like this. Does that look like a right triangle to you guys? Well, it is, because right there. So you gotta be careful. A lot of times people get confused when the top angle is the right angle or the obtuse angle. They expect it to be like on the bottom or something, I guess. I don't know. But anyways, it can look like that. I had an idea in my head and I forgot what it was. Oh, what do the angles of a triangle always add up to? You guys know? 180. So, in a right triangle, if this is 90, what does that leave for these two?
45.
No, that's it, only if they're the same. It leaves these two together have to be 90, right? So anyway, the three angles have to add up to 180. Okay, that's classifying triangles according to their angles. You can also classify triangles according to their sides. If you have three congruent sides, what's it called if all sides are equal? Equilateral. Is it possible to draw a different equilateral triangle than that one? Well, what's wrong? You're getting emotional with math? No. I get it. Okay. You can make it bigger or smaller, but no, it's always going to look like that. There's only, if you don't have like three exactly similar things, there's only one way to hook them together. So all these sides are congruent. This is kind of extra info, but if you have that, all these angles would have to be congruent as well. So do you know what each of those angles would have to be? More specific than acute. It is an acute triangle, yes, as well. 60. You guys know how you got that? 180 divided by 3. Okay, if they're all the same, 180 divided by 3. All right, so all three sides are the same. About if two sides are the same? Does that look the same? As close. Isosceles. Do you actually remember that, or you see it in the book?
No, I remember.
All right. Nice. draw isosceles triangles that look different than that?
Yeah.
Yeah, there's lots of kinds. This is isosceles. This could be isosceles, if I drew it carefully. It could be isosceles. They can look quite a bit different. So if I have three equal sides, what comes next? One equal side? I knew that was going to happen. No equal sides. It's kind of a little tricky to draw this, but that kind of looks isosceles.
Isn't it scaling?
Yes, the last one is scaling. No equal sides. Yeah, it's hard to, you gotta be careful drawing scaling because it's easy to make it look like an isosceles. I mean, this is technically probably not accurate exactly, so it's probably technically scaling. But yeah, 0 equal sides. Okay, so it's possible to be both of these things. Like you can be one of these angle things and one of these things. For example, we said this is equilateral, but it's also acute, right? This is isosceles acute, because all three angles are acute. This is isosceles what?
What? Isosceles obtuse?
Right, or obtuse isosceles. I don't think there's really an order to it. This is isosceles and right. This is scalene and acute. This would be obtuse scalene. So anyway, look like a lot of different things. All right, are we having fun yet? All the angles of triangle add up to 180. The two, what did we say about the two non-right angles in a right triangle?
Oh, they're acute.
More.
They add up to 90?
They add up to 90. Because this is 90, that leaves 90 for these two. So they're complementary. Remember that word? We didn't use it very much. Complementary angles, the non-right angles. Equilaterals have to have 60. Those are theorems, by the way, that we can use. Or we're not going to prove it, but we can just use them. The book says it, so we can use it. In a triangle, if two angles are congruent to each other, like in two triangles, let's say this angle is the same as this angle and this angle is the same. So in two different triangles, if we have two pairs of congruent angles, guess what I know?
They're all different.
The third pair has to be congruent. Like, so for example, let's say I knew this was 50 and this was 50 and this was 80 and this was 80. Well, what do I know about the last angles?
Has to be.
They both have to be whatever adds up to 180, which would be the same thing, right? So if two pairs of angles are congruent in two triangles, then the third pair has to be congruent.
Wait, but wouldn't the last one be 50?
It would be 50 as well, but that's just random. I could have made this a 70, and this would have been a 60. Anyway, you guys get the point, right? By the way, this is kind of a little bit down the road, but do you have to have the same size triangles to have the same angles? No. This is an equilateral triangle, 60-degree angles. This is an equilateral triangle, 60-degree angles. Okay, it doesn't matter the size for the angles. Okay, two more definitions. This is new. If you extend like a line on a polygon, the angle that's created out here is called an exterior angle. Alright, guess what we know about an exterior angle and the interior angle that it's right next to? They add up 20. So this would be an interior, all these are interior angles. And these two guys right here, X and Y, they would be the remote interior angles. You guys know what remote means? What do we use a remote for?
Control.
Change the channel from far away. What's a remote desert island? Far out into the sea, okay? So remote means far away. So these are remote interior angles because they're far away from our exterior angle over here. So these two add up to 180, right? That guy and that guy. And what do I know about these three? They add up to 180. So that tells me something. You guys know what it tells me? If Z and W add up to 180, and X, Y, and W add up to 180, then what? Z and X plus Y must be the same thing.
Yeah.
So an exterior angle of a triangle is equal to the sum of the remote interior angles.
That would be fun to remember.
Yeah. If I put some numbers in there, it might be easier. But, yeah. Like if this one looks like it's about 120 or something. And if I knew this was like 70, then this one would have to be 50. Those two would have to have that. I mean, you can kind of not remember because if I know this is 120, I know this is 60. And if this is 70 and this is 60, I can subtract that from 180. 8. Talk. Number 1, classify each triangle by angle measure and side length. So 1 through 4, these are going to have 2 answers. You guys ready?
No.
4 answers?
I'm trying to remember what time we got out today.
55.
55. Caleb's got it memorized. All right. According to its angles on number 1, what kind of triangle is number 1? Right, because there is one right angle. That's all you need. That's all you can have. According to its sides, what kind of triangle is number 1?
Obtuse.
Obtuse's angles. Isosceles. Sorry, I was wrong. Isaac was right. All 3 of those are different. The one on the left is small, one on the bottom is medium. The hypotenuse, you guys remember that word, is always the largest. So it is scaling. Number 3. The order doesn't really matter, but they're doing the angles first. So based on the angles on number 3, what kind of triangle is that? Acute angles. And when they put those little dash tick marks on the side, they're telling you that these are the same. That's what that means. So if all 3 sides are the same, it is equilateral. By the time we take the test, which might be a while because of fall break, you do need to know all these words by heart. I think you guys got most of them already. Maybe just scaling and isosceles, right? Those are the ones that are kind of hard to remember. Draw, yeah.
Yay.
Time for some drawings. Draw and mark a triangle illustrating each. If such a triangle is not possible, explain why. So they're hinting that one of these is not possible, at least. Number 5. Is it possible to draw an acute scalene?
Yes.
Yeah, actually one of my examples, example was acute, right? Remember that one? Just gotta be careful, make them a little bit different. But yeah, it's basically that thing. Whoops. I'm not gonna be super picky, but to make them different, you have to make all the angles different. It's kind of hard to tell. Like it should be, see how it's kind of like a triangle that's leaning to the side a little bit? Not sure that's my best one. Let me try this. That's good. But if it's supposed to be acute and you make one of the angles like obtuse, I will count it wrong. So I'm not going to be picky, but I am going to still grade it. Number 7, obtuse isosceles. How is that possible?
Right.
Why don't you guys try and draw one? We'll see. My advice, start with the obtuse angle. Make sure you get that in there. You don't have to do it that way, might be easier. Okay, there's a lot of different ways to draw it. You guys see it? Obtuse and isosceles. Isosceles meant this, right?
No.
Yours might look different and still be right. Like you could flip it around or something. Because, there. Is that good? Huh?
Number 6 would count I don't know.
It's number 8.
Yeah, remember we said equilaterals are always 60, 60, 60. Yeah, number 6 is possible. You just have to make the legs the same. Okay, number 9. Refer to isosceles triangle MTS. By the way, there is a triangle symbol. So to name a triangle, you put triangle symbol like ABC. Alright? There's not a quadrilateral symbol, there's not a pentagon symbol, there's nothing, but there is a triangle symbol. Why not?
Why not hot?
Probably so, because that's also what angles look like. So sometimes you might want to say angle ABC, and sometimes you might say triangle ABC. That's probably why. Okay. So I didn't mention this, but in an isosceles triangle, they named the parts. Kind of like they named the parts in a right triangle, but we're going to do more on right triangles later. The two equal sides they call the legs. Anybody want to guess what the not equal side is called? Base. Okay, now the tricky thing is it could look like a lot of different things. This is not necessarily what an isosceles triangle looks like. But the two equal sides are always the legs. The other side's the base. These are called base angles. And on an isosceles triangle, base angles are always congruent. This point up here is called the vertex angle, which is a terrible name because all corner points are called vertices, a vertex, yeah. So I don't know what they're thinking. They weren't thinking when whoever did that, but Same thing on a pyramid, they call that top point the vertex point. Anyway, so it's confusing. So technically these are also vertices though, but this is the vertex angle. Kind of like the Ohio State University. Never mind. Number 9. Name the legs and the base. I just remembered a joke.
Jerry told me about that.
Daniel Marquez was talking because a couple years ago about where he's going to go to college. And he said, what was it? I think it was the Coffeyville Community College or something like that. Anyway, let's move on. So on 9A,
Same.
you guys didn't get it?
No.
Maybe you haven't heard the thing before. What are the legs on that triangle?
Yeah.
The legs are the equal sides. So what are the equal sides? TS and no,
Oh,
MS. And TS and MS are what?
Line.
Segments, right?
Yeah.
TS, MS, semicolon. What is the base? TM. Okay, on B it says the vertex angle and the base angles. So the order does matter, because if you just list all the angles out of order, so you do need to say the base angle first. That's still at 9. Okay, what is the base angle, or vertex angle rather, on no, the vertex angle was S, the one that's kind of off by itself. Angle S, and then what are the base angles? Okay, what do you notice about the base angles?
They are equal. They're congruent.
Yeah, congruent, they're the same, something like that. Let's see what they put. They are congruent. Okay, 10. I'm not gonna do it, but we'll talk about it. And we've done this one before. You guys know what the sides of a right triangle are called? What's this side called?
C squared.
The big side, the side across from the 90-degree angle. We talked about this in Algebra 1 a little bit. What are these two sides called?
The legs.
Okay, so isosceles triangles have legs. Right triangles have legs. And yeah, I think that's all we need. Do you guys remember the relationship between the legs and the hypotenuse?
The legs together equal the hypotenuse?
No, not quite.
Oh, Pythagorean
Leg squared plus leg squared. We're not really doing this today, but we will do it, of course.
On A for 10, you put the numbers, you put the line segments.
Segments. The name of the segments are like, A, B, X, Y, that kind of thing. Okay, number 11. Find the measurement of angle A. Isaac, how could we find angle A on number 11?
Is it all equal to 180?
Yes.
Okay, so 65, 65. And angle A equals 180.
So how can we solve it then? He said 65 plus 65 plus angle A equals 180. But how would you solve it? 180 minus 65 plus 65. Yeah, you could think of it like this. Or you could think of it like this. Yeah. 180 minus 130 is 50 degrees. So you could add them together first and then subtract from 180, or you could just do 180 minus 65 minus the other 65. Okay, Cadence, how could we find angle ACD?
So, angle C is 180 minus 65?
Yes, it's a linear pair with that 65-degree angle, so 180 minus 65 would get it. What is 180 minus 65? 115.
Can you just add 60?
Wait, that's not what it asks for. It asks for angle ACD.
Yeah, that's what I said.
Didn't you say the two other?
Oh, the two, yeah, that's also, you could also get that by adding the two remote interior angles. So we could have added angle B plus angle A to get the answer also. But Cadence did 180 minus the 65 for angle ACB. Which is fine. Same. Number 13. So, you guys see on 13 they put those little red arcs. What do you think that means?
Equal?
Those two angles are equal, so it's like an isosceles. But we're just looking at the angles right now, not the sides. So, how could I find angle KIH?
Subtract 180, or 140 from 180.
Right, 180 minus 140, so that's 40. They didn't put an A and B on those, I just realized. I'm doing it anyway. So we got KIH is 40. And then Natalie, how could I figure out angle K?
Just find out what each one are.
Well, we just found KIH, which is what I assume you mean by angle I.
Yeah.
So that's 40. So what does that tell me about angle H?
Is it also 40?
It's also 40. The reason we know that is because the red arcs tell us that.
And then there's K100.
Yeah. Right. So the bottom two, the base angles are 40 and 40. So together that makes 80. So 180 minus 80 leaves 100 degrees. Should we finish this section? Yeah, let's finish this section and let you guys work on the evens. Looks like a little bit of algebra, number 15. Did I skip one? No. Okay, on 15. Uh-oh. Jarrett says he wants it. Okay, Jarrett. Crick. It's like the one time I don't know. What's the relationship between those three angles that they drew? If X is an exterior angle, it should be equal to the remote interior angles. You guys know what I'm talking about? So X is an exterior angle to that triangle, so it's actually equal to angle L plus angle M.
How?
Well, you guys remember me talking about, I don't know where I put that.
50, right?
Yeah,
Okay.
let's see if I can find where it was. Right here. Okay, remember I said that an exterior angle in a triangle is equal to the sum of the remote interior angles. Okay, that's what's going on here. On 15, the angle LNO, that exterior angle, x degrees, is supposed to be equal to the sum of angle L plus angle N, the remote interior angles. So we're kind of using a trick here. Another way I could have solved this is if that outside, that exterior angle is x, then the angle right next to it would be 180 minus x. You guys know what I'm saying? Because they're a linear pair. If the outside angle is x, the angle right next to it would be 180 minus x. Then all three of those angles, you could say add up to 180. That's another way to do it. But let's probably stick with the exterior angle. Exterior angle, x degrees, is equal to the sum of the other two far angles, x minus 60 plus x minus 20. All right, algebra time. Jarrett, what should we do? Add the x, add the like term, simplify the right side. X plus x minus 60 plus minus 20. Okay, if we have x's on both sides of the equals. By the way, I was a little bit disappointed on our algebra number, like what was it, 5 on the test? A lot of you said like negative 14 minus 8, or no, it was like, what did the test say? Okay, well, it was number 2 after the first 3, A, B, and C. A lot of you put like negative 18 minus 4 was negative 14 or something like that. Or 4 plus 18 is, I don't know. Most people who missed that made a mistake right there. Anyways, minus 2x. Negative x is negative 80, so x is 80. What are we looking for though? The first question is, what is the measure of angle ONL? What's the measurement of angle ONL? 80, that's because it says x. So 80 is actually the first answer. And then let's all just leave that there, 80 degrees. What is the measurement of angle L? Angle L says x minus 60.
Oh, negative.
So 80 minus 60. We just found out x was 80. So angle L is 80 minus 60. 20. Angle M is x minus 20, so 80 minus 20. And angle LNM. How could I find angle LNM?
You do 20 plus 60 plus 8. Or just 8, right? That's 180, right?
Yes. Okay, we just said 80, 20, 60. What's this thing? Okay, these two, what do I know about these two? They add up to 180. What do I know about these three? They add up to 180. That's why this is the same as these two, because they add up to 180. Anyways, 180 minus 80, or 180 minus 80, would give you this answer. So that's 100.